Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 5, Lesson 14.
Module 5, Lesson 14. Let's get started.
All right, I want to show you a couple different types of problems that you're going to be doing today. The first is where you are given some information like this. The area of the base of the sandbox is given to you. So we have area, and I want to remind you of our formula to find the volume of any object is any prism is volume is equal to area of the base times the height. Area is equal to, volume is equal to area of the base times the height. And notice that in our problem they gave us the area of the base. So I'm going to plug in the area of the base into my formula. And right here is where area of the base is. So I'm going to put a 9.5 right there. And then they also showed me that the volume is 7 1/8 cubic feet. So I'm going to plug that in also. Volume is right here. So I'm going to say 7 1/8 is equal to the area of the base, which they told me was 9.5 square feet, times the height. So there's my equation. I notice I just have one variable, and I'll be able to isolate that variable to solve for the height. If these were just numbers, I think it would be very easy for you since we did the algebra unit, but they're mixed numbers, so they're a little bit ugly. But you have to know how to deal with mixed numbers, because on the test there's going to be mixed numbers. There's going to be fractions and mixed numbers all over the place. So you got to be able to figure out how to deal with them. So let's change these. I'm going to use the reverse C method to change this from a mixed number into an improper fraction. And by the way I do that is I multiply denominator times whole number, and then I add the numerator. So 8 times 7 is 56, plus 1 is 57, and I keep the denominator, 57/8. So 57/8 is equal to, and let's change this one. This is 2 times 9 is 18, plus 1 is 19, and I keep the denominator 2. So 57/8 is equal to 19 halves times h. And now I'm just going to use algebra, and I know that if I, since this is multiplication between 19 halves and h, I can undo multiplication with division. So I'm going to divide by a fraction. Except I remember, I can't divide by a fraction. I have to multiply by reciprocal. So I'm going to flip this upside down and multiply. And that allows me to cancel out the 19s, cancel out the 2s, and I get what I want, which is h isolated. But remember, whatever I do to one side of the equation, I have to do the exact same thing to the other side of the equation. So I'm going to multiply by 2 19ths on the other side. Now here I would suggest that you simplify before you multiply. And notice that this 2 and this 8 have a common factor of 2. So divide them each by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. And now I have a little bit easier multiplication. I also recognize that 19 and 57 have a common factor, and it is 19. So 19 divided by 19 is 1, and 57 divided by 19 is 3. So my answer here is, let me get a new number, or a new color here. 1 times 3 that's 3, over 1 times 4, that's 4. So my answer is the height is 3/4 of 1 foot. Okay, all we did was use the volume formula for any prism. Volume is the area of the base times the height, and we substituted in what we knew to solve for the one dimension that we did not know, in this case the height. All right, that's number 1. Number 2 in your book is a little different, kind of the same, because we've done this before with 2-dimensional objects and finding area. Now we have to find the volume of a 3-dimensional object, and you can do the same techniques. You can compose, which would be to make a big rectangle, sort of like this. Let me see if I can, I'll just draw it here. Could make this big rectangle, right, the whole thing, and then subtract out the empty space, so compose. Or, let's get that out of the way, or you could decompose. You could kind of cut this up this way, and we'd have a rectangular prism here on the left, that one back there, and then we'd have a rectangular prism here on the right as well. So either way, you can do whatever you want there, but the fact is we have to find the volume of each prism. So I'm going to do a decompose here first, and I'm going to find the volume of the left side, and then I'm going to find the volume of the right side. So let's find the volume of the left side first. I need 3 dimensions. Let me find the 3 dimensions here. I'll use red. I'm going to need this dimension right here. I need that distance. Looks like that's 2 3/4. So that's length, 2 3/4. I'll need width, which is going to be this dimension right here. And that dimension matches this. So that's 2 meters. So I'll multiply by 2 over 1. That's 2. And then I'll need a third dimension, which is going to be the height. So I have length, width, and height. And the height is 1/5. It's over here. The height is 1/5. So to find the volume of the left prism, this one that's in red, let me just outline it all in red. That one, the one on the left side, that's going to be 2 3/4 times 2 times 1/5. All right, and we can't deal with this yet, so I'm gonna change this mixed number into an improper fraction. Remember, 2 times 4 is 8, plus 3 is 11/4. So this is 11/4 times 2 over 1 times 1 over 5. And then I'm going to simplify if I can, and it looks like 2 can go into 2 one time, and 2 goes into 4 2 times. And that's about it. So the volume of the left side is going to be 11 times 1 times 1, that's 11. And 2 times 1 is 2, times 5 is 10, 11 tenths, which is 1 and 1/10 cubic meters. There's the left side. And now let's find the right side. The right side, let me erase a little bit here. I don't want to erase everything. I just want to erase, let me get this here, this right here. There we go. And so here's the right side. Let me outline it so you can see it. It's all of this. All of that blue part. So we need length, width, and height. So let's see, I have this length is 2 1/4. So I'll have 2 1/4 times the width is 4 1/3. 4 1/3 times the height is 1/5. All right, and then I can change these. and this is a 4 times 2 is 8, plus 1 is 9/4, times, change this one, 4 times 3 is 12, plus 1 is 13/3, times 1/5. And let's see, 3 and 9 have a common factor of 3, so 3 goes into 3 once, and 3 goes into 9 3 times. So I can do that, and that looks like that's about it. 3 times 13 is 39, and 4 times 5 is 20. So I get 39/20, which is 1 with 19/20 left over. Cubic meters. Now to get the total, I'm going to add these together. So I could either use the improper fractions, or I could use the mixed numbers, but I think improper fractions are going to be easier. I'm going to use these two to add together, and in order to do that, I need to make my denominator here into a 20. So I'm going to multiply this by 2 over 2. That gives me 22/20 plus 39/20, and if I add those two together, I get 61/20, and I know 20 goes into 60 3 times, and I'll have 1 left over. So there is my total volume of the composite figure. That's decomposed. You could also compose by making a bigger rectangle or a bigger prism around the whole thing and then subtracting out the empty space. Either way will work. Okay, that's your practice today. I hope that helps. Good luck. See you next time.